So as part of our unit on quadratic equations, we're now going to be looking at solving quadratic equations. In its general form, a quadratic equation is given as ax squared plus bx plus c. If we look at the word quadratic, it comes from the word quad, which means square. And if we take a look at the variable x at the start of this equation, we can see that it's being squared. So this is why we call it a quadratic. So I'm just going to write variable is being squared. Alright, so examples of quadratics can include the following, and they're not limited to, so just keep this in mind. 4x plus 6, it could be 3x squared equals 5, or it could be 4x squared equals 25x. Notice that in each of the examples that I've given, we can see that the variable or the x variable has been squared each time, thus making it a quadratic. So it's the highest power as well in each of the expressions, so we know indefinitely that they are quadratics. So when we look at solving quadratic equations, it requires you to carefully apply your algebra skills that you have acquired through previous units, and it requires you to find the value of x, which satisfies the equation. So we'll come back to the second notion when we're doing our worked examples. And it's really important to note as well that some quadratic equations have two solutions, some will have one, and some will actually have no solutions. So coming back to the point where I said that we need to find the value of x that satisfies the equation, if we take a look at the first example where we're told 2x squared minus 18 equals 0, what we're trying to prove here is that the left-hand side must equal the right-hand side. So here I'm going to write left-hand side must equal the right-hand side. So we need to find what value of x allows the left-hand side to equal 0. So let's go ahead and solve this. So remember, we're trying to solve for x, so we're going to move the negative 18 over to the other side. So that'll become 18. Now I'm going to divide out by 2, because remember it's 2 times x squared. So dividing the 2's out, we're left with 1, and 2 goes into 18 9 times. So now we've got x squared equals 9. But we're not done here, and this is because we've got the power. So remember, we're solving for x, not x squared. So now what I'm going to do is I'm going to apply the inverse operation to the square, which happens to be a square root. So if I do the square root of 9, what I'm going to get is that x could equal 3, or x could equal negative 3. Now, the reason I say that x could be 3 or x could be negative 3 is because if I do 3 to the power of 2, it's the same as saying, 3 times 3, which is equivalent to 9. I could do the same thing by doing negative 3 to the power of 2, which is the same as saying negative 3 times negative 3, which also gives me 9. So we need to acknowledge the fact that x could be either positive or negative, because when we're squaring the two together, we're going to result in a positive 9, whichever way we go. Now this is really different to having 3 to the power of 3, because if we do 3 times 3 times 3, we're going to get 27. However, if we do negative 3 to the power of 3, that's the same as saying negative 3 times negative 3 times negative 3. Negative 3 times negative 3 is positive 9, times by negative 3 is equal to negative 27. So just be aware that whatever the number or what power it's raised to does impact the answer. So if we come back to this worked example, x could be 3 or x could be negative 3. So in this case, we've just proven that two solutions exist. And if we want to just quickly check that we're correct, let's substitute 2 times 3 all squared minus 18, and let's see whether or not that equals 0. So first we need to deal with that. So that becomes 2 times 9 minus 18. 2 times 9 is 18 minus 18, we get 0. So we know for a fact 3 is correct. Now let's substitute negative 3 into the expression. So 2 times negative 3 all squared minus 18. So again, we're going to have to deal with that first, and that becomes 2 times 9 minus 18. 18 minus 18 equals 0. So I should probably get rid of the exclamation point, because that does actually mean something in maths. So we can see that both positive 3 and negative 3 do give us a solution of 0 each time. In the next example, we're given the expression x squared plus 16 equals 0. So again, what we're trying to find here is the value of x that will allow the left-hand side of the expression to equal the right-hand side. So remember, we want left-hand side to equal our right-hand side. So I'm going to rewrite the expression so I can start moving things across. So I'm going to have this this positive 16. When I bring it over to the right-hand side, it's going to become negative 16. So I'm just going to write that there. That will become 0. So I've got x squared equals 0 minus 16 for negative 16. Now, unfortunately, we have to stop here purely because negative numbers do not have a square root. So therefore, we can say that there are no solutions as negative numbers Alright, then we move on to the next example. So we're given the expression 2x to the power of 2 plus 5 equals 5. Again, remembering that we want left-hand side to equal our right-hand side. So I'm just going to rewrite this out again. So my first action is going to be to take this positive 5 over to the right-hand side, making it negative 5. So I'll be left with 2x squared equals to 0. Now, if I take the 2 to the other side, if I divide by 2 both sides, that will cancel out to leave me with x squared equals 0. So therefore, we only have one solution. As 0 only has one square root. Now, for the moment, it may seem kind of pointless as to why we're solving all of this and not know what it could look like potentially visually. However, just know that we are working towards actually graphing these expressions, and once we graph these, the purpose of us solving for x becomes quite apparent as we start to look at intercepts. So just keep that in the back of your mind, that we are trying to build the foundations towards us graphing quadratics. So last but not least, we have the example 3 times x plus 2 all squared equals 27. Now this is a bit of a complex question, and you need to fight the urge to expand your brackets at will, because this does require you to do a little bit of reshuffling, and once you start to do the reshuffling, you can break it down. You'll find that you don't need to actually expand the expression at all. So the first thing I'm going to do here is I'm actually going to divide the left-hand side by 3 because of this 3 here. And if I divide the left-hand side by 3, I'm going to divide the right-hand side by 3. Doing so, the 3's go into 3 once, and then 3 goes into 27 9 times. So what I'm going to be left with now is x plus 2 all squared equals 9. Then what I'm going to do is I'm actually going to take this squared and I'm going to square root that on the other side. Remembering what I said before, that if I square root a positive number, I could have either a negative number or a positive number. So what that means is I could have x plus 2 equals positive 3, or I could have x plus 2 equals negative 3. Remembering that the square root of 9 is 3 or negative 3. So now I've got x equals, I'm going to, if we take a look at x plus 2 equals 3, I'm going to take that to the other side, and that'll become 3, whoops, that was very unclear, negative 2 plus 3, that'll give me x equals 1. And if we look at the next one where it's x plus 2 equals negative 3, I'm going to take this positive 2 to the other side. Again, that'll become x equals negative 3 minus 2, giving me x equals negative 5. So you can see here we've ended up with two solutions, two very different solutions, but what we're told is both of which will give us the answer of 27. So we'll do a quick check with this one, considering how different the numbers look. So when x equals 1, let's check and see what we get. So we have 3 times 1 plus 2 all squared, and what we need for it to equal is 27. So let's look at this. So we've got, deal with the brackets inside first. So we've got 3 times 3 all squared. So 3 times 9, giving us 27. Then the other one was x equals negative 5. So we've got 3 times negative 5 plus 2, and that whatever's inside the bracket all squared. So let's deal with the inside of the brackets first. So we've got equals to 3 times minus 5 plus 2 is negative 3. I'm going to square that. Remember I said before that a negative number squared is going to end up with a positive number. So we've got 3 times 9 equals to 27. So both of which match the 27 in the question given. So we know that our solutions of x equals 1 and x equals negative 5 are correct for this particular expression. And that's it on solving quadratic equations in the form of y equals ax squared plus c.